CRUD is a bad idea and that you should focus on real scenarios instead. So, I am a programmer my whole adult life. I love clean code, regular expressions, and clever design of all kinds. I spent at Shopsys over 5 years of my life, and I dedicated the last year to Shopsys Framework, our platform for making e-commerce that is open source. We are currently at closed beta, so you can join us through a form. We are not publicly released yet. We are made in PHP and Symfony 3. You can contact me, of course, at my email address. So, what a typical CRUD is. First, we are here all after lunch, so let's get some exercise. How many of us are here developers? Please put your hands up. Great, almost all. Who knows what a CRUD is? Great. And who knows exactly what this acronym stands for? Great. A lot of hands up. So, CRUD means create, read, update, and delete. Those are 4 basic functions of persistent storage and are often used as an API. Its big advantage is that it's very simple and can be mapped to SQL statements directly. Insert to create, select to read, and of course update and delete. And it can be mapped also to HTTP methods. So put, get, post, delete. This is mainly used in REST APIs. This is an example of writing CRUD in PHP. So we have here some entity article that has 4 properties. Every article has some author, some text, state, and date of publishment. Here we have some article controller that has those 4 CRUD methods. It has no read, but it's not important for this presentation. Here we have some update that gets some request, somehow gets an article and parses those 4 attributes from the request and simply uses a setter. The problem with this approach is that entities must always follow some business rules, some constraints, because you can imagine in this article that when it is in published state, it must always have some date of publishing. Similarly, products, when their inventory goes to 0, it should be updated to be hidden. Or when a customer that is from a company, he needs to have VAT ID filled in his account. And these rules are a bit difficult to achieve in this previous example, because in some other part of the application, we can use the setter state and set the state published, but not use the setter published. And then we have an inconsistent article. So the properties can be changed independently, and that poses some problems to our architecture, because the developers are not restricted in the way they interact with our object. So we can do something like this and move those CRUD methods into the article directly. So now when the article is constructed, it has provided all the properties it needs and can have some logic internally to keep this consistency. Here we can have some soft delete implemented like this. We can look at the update method of the article. And we can see that it cannot be updated when it's deleted, and when it's published, it has the published date set it here. When it's unpublished, it's always null. So by this approach, we can always ensure that our entities are integrous. This looks like a solution to our problem, but allow me a quick detour to what are objects in object-oriented programming. Objects have both data and some behavior. The data is their properties, the behavior is their methods. Objects should model some real-world behavior, real-world concepts, and relationships. The most important principle in object-oriented programming is, in my opinion, the encapsulation principle that tells us to hide the details about the data and only offer the meaningful behavior we should expect from our objects. It's under this rule, tell, don't ask. Just tell the objects what to do, don't ask them for some data, because that should be hidden as an implementation detail. Unfortunately, in PHP, it's very easy to combine procedural and object-oriented programming. We can imagine that simply by using the keyword class, we are programming object-oriented, but we can really do some procedural code with objects. This is an example of a real object, some bank account, and you have two meaningful actions that you can do with your bank account. You can either deposit some money or you can withdraw some money, and there is no need for set balance or something like this. You have only the meaningful actions. In modeling some domain, when we are designing, there are two main ways to do so. Those are called dynamic domain model and rich domain model. Are you familiar with those concepts? Anybody here? Yeah? Okay. So, to explain, let's define some terms first. The first term is domain. It has some dictionary definition, a sphere of knowledge or activity, which is not very explaining. It's basically the subject area of your application, the thing your application is about. It can be an online store, it can be news site, that's your domain. Domain model is then system of abstractions to model the relationships, the behavior of the domain. It's just a simplification of the real world in terms of code. Domain object is then a part of this domain model that is an object. For example, product, order, bank account. And then there is business logic, which is high-level logic reflecting the real-world business rules. Also, it's called domain logic. So, let's look at dynamic domain model and rich domain model. In a dynamic model, there is no business logic in domain objects. All the domain objects are just getters and setters and some data. All the business logic is then in service layer above it, and this approach clearly separates the logic from the data. This can look as a good thing, because it separates some concerns, but it really violates the object encapsulation, because those domain objects have all their properties public in terms of the setters, and any part of your application can independently change their inner data. I must say that it works well for simple applications. So when you're starting with your application, it might be the way to go. But it leads to procedural programming, and Martin Fowler calls this an anti-pattern. On the other hand, rich domain model, in this model, the business logic is kept mainly in the entities themselves, in the domain objects. This means that the service layer is very thin or non-existent at all. The domain objects encapsulate their inner data and only offer some meaningful behavior. This is very important for the object-oriented code and leads to very integrous data. The data integrity is kept by the encapsulation. And for exactly this reason, it's better choice for complex domain models. When your application is very big and you need to think about the data integrity, you should go for the rich domain model. I have here some pretty simple example. We have a class worker that can do some work, and this class has a property velocity, which means how quickly this worker gets the work done. So in anemic domain model, this velocity is published via getter and setter. And then we have some service layer, a worker service, that has all the logic in it. So it has some function work, and a worker can work on a task for some time. Here we see the procedural code, because procedural code first gets some data, then makes some decisions, and then just saves it. On the other hand, rich domain model, we have a class worker here, which is directly constructed with this velocity and cannot be changed in its lifetime. And we have meaningful method work, which means that this worker can work on a task for some time. This allows us to keep the logic of the working, how the progress is made, directly in the class worker, so it's encapsulated. We can see here that the task itself also follows these rules. So instead of get progress and set progress, we have here a method make progress, which really restricts us in the way we interact with those objects. Because in anemic domain model, we can imagine a scenario where some progress is undone. Somehow we set progress to 0 or something like this, and this is restricted in the rich domain model by the only way to interact with this object. The task can only move further. So, it seems that the problem lies in setters. And the thing is, setters, as we use them in programming, have no real analog in the real world. Setters have no real meaning. There is no set in reality. For example, a writer does not set a state of published to an article, he publishes it. Customers do not set a paid status to their order, they simply pay for it. And when you make your boss happy, he does not set your salary to some higher value, he just raises it. There is always a better and more expressive alternative to a setter. And when your code is expressive, it leads to easier maintaining, easier using your interfaces, because the code is more readable. The problem is that nobody expects setters to contain logic. Oftentimes you need some logic while updating your property, and you might feel the need to put the logic into a setter. You can validate some values there. You can even use some kind of mail service to send some emails. But would you really, when using order set status to something, would you expect it to send an email? Probably no. When you have unexpected behavior in your application, when your methods cannot be expected, it leads to bugs. And this can be simply solved by removing the set status and just including two methods with some meaning. You can include a method pay for setting the status is paid, and you can cancel an order. And now you just simply expect the method pay to do stuff, to have some logic implied. These are, of course, very simplistic snippets of code, because it's very hard to put some code onto such limited place. So the U in CRUD, the update, is in essence very similar to a setter. It has no real meaning. There is no updating stuff in real world. We always do some meaningful action, something that has some expressive name and has some logic in it. For example, when we update an article, we mean possibly that we want to rewrite it and publish it or unpublish it or delete it. We are doing some actions that should be named in the code. Let's summarize and make some recommendations on the things I just said. My first lesson is that you should focus on real scenarios. It's the subtitle of my talk. Because when you focus on real scenarios, on those real use cases, real actions that can be performed on your objects, on your domain objects, you get expressive object-oriented code that is very easy to understand, use, and maintain. The concept of setting or updating is simply too generic to be meaningful. When you're designing your API, you should always focus on what the users will do with those objects you offer them. You should focus on real use cases. And by doing this, you should keep your APIs clean, intuitive, and really easy to maintain for you as well. And when using real scenarios, real methods, you can keep the integrity of your data always by the encapsulation principle. Also, you should always think about the way you program, because there is no silver bullet, no best way. It cannot be said that object-oriented code is better in essence than procedural code. As Pavel said, those things are just tools. We need to know how to use them and use them well. You should keep in mind the techniques of object-oriented programming and not think that just by using the class keyword you are writing in object-oriented style. You should keep in mind the encapsulation principle and keeping the inner data private inside the objects you are making. and focusing on the public behavior, on their public behavior. By knowing about those two extremes, the anemic and rich domain model, will help you to design your APIs better and really choose a better way for your exact application, for your exact project. And when you, for some reason, need crude methods, you can always add a layer. We see here the previous example of an article with a method update. And by using adapter design pattern, we can change this to an article CRUD adapter. Here we have our rich domain model article with some meaningful behavior. And in this adapter, we have a public method update, which is using just those methods that have real-world meaning, and we can expect their behavior, and we are using them in a meaningful way, instead of just setting stuff. As always, it's about the balance. As I said, there is no real silver bullet. Every way has its trade-offs, and you should pick your own way. Focusing on real-world use cases will help you to maintain the integrity of your data, which is very important in enterprise applications, in complex models, because when you do not do this, your application just comes into a mess, and when any part of your application can change any data independently, this leads to bugs and unexpected behavior. When integrating with other libraries like Symfony, Symfony Forms, Doctrine, etc., it's, on the other hand, easier with generic methods, with those setters, with those getters and updates. But this can be overcome with some additional layers between the library that we are interacting with and our integrous data models. When we are developing the Shopsys framework, we try to keep that in mind and focus on the real behavior, especially when we are naming our methods, because it's very, very important to name methods expressively. So you should always expect the behavior that is really implemented. And I would like to invite you to see for yourself and join our closed beta just by going to shopsysframework.com and there filling a beta form. You can see what we did there. Thanks for listening, and if you have some questions, let's hear them now, or you can talk to me afterwards.
Teraz czas na chłopaków z Virtual Expo. Będzie to trochę taka niespodzianka, aczkolwiek panowie się u nas pojawili i chcą zaprezentować coś o swoich targach. Więc krótka 10, myślę góra 15-minutowa prezentacja będzie o Virtual Expo, a tuż po niej dwaj kolejni koledzy z Orange.
Jeszcze 2 minutki i zaraz to możemy zmienić preskę akurat.
Kiedy się przydaty, bo I disconnected.
Sure. Co chłopaki tutaj dla was przygotowali. I chciałbym, jestem wrocławskim startuperem, robimy pierwsze w Polsce wirtualne targi pracy, czyli wszystko przenosimy po prostu do internetu. Wiem, że w 90% tutaj jesteście programistami, mamy dzień stricte dla programistów 26 października i chciałbym Was serdecznie po prostu zaprosić na ten event, ponieważ tak jak dzisiaj tutaj są merytoryczne prelekcje, tak samo u nas będą merytoryczne prelekcje, tylko wszystko będzie się odbywało online. Czyli będziecie mogli się spotkać z ciekawymi firmami, takimi jak Samsung, takimi jak Bayer, takimi jak Bridgestone, które opowiedzą Wam o możliwościach w danej firmie oraz przedstawią po prostu to, co robią. Na naszej platformie można porozmawiać po prostu z rekruterami, zobaczyć jak to wszystko wygląda. I są to targi pracy przygotowane tak naprawdę dla ludzi, którzy siedzą tylko na komputerze. No i w gruncie rzeczy to jest mój przerywnik. Chciałem Wam pokazać to, co się dzieje we Wrocławiu i serdecznie Was na to zaprosić. Dzięki.
Okazuje się, że to nie 10.
Let's start our presentation. Let's probably start from the topic itself. So it's Modular application architecture tips and tricks. In this presentation, I'm going to talk about not only architecture, but about good things about architecture, bad things about architecture, and architecture in general as it is. So as usual, first slide about me. My name is Yevhen, or Eugene. Feel free to call me whatever you wish. I'm having about 10 or 12 years in the software development already. 5 of them, even more than 5 of them, are in the e-commerce business one day or another, and during that business I has been developer, I was team lead, tech lead, system architect, tech writer, partial QA engineer, and so on and so on. So during all this stuff I have learned a lot, not only as a developer but also as a person who communicates with the other people, communicates with the business, or communicates with the people who are making decisions, who are required who actually setting requirements, and so on and so on. Right now I'm working in a company called Wro Inc. We are developing several products at our CRM or platform or commerce. I'm not going to talk a lot about these products because it's not a topic of presentation. Just a couple of things about the products, that they are open source module products. So we have an open source conference, that's why we are going to talk about that. We have released our products 4 years ago, so we are already 4 years in business. We are 4 years working with the customers, and we learned a lot about architecture. We learned a lot about how to work with people and how to interact with them, and this is actually an experience I'm going to share during this presentation. Starting from the release of our application, we have learned a lot about what open source for big business and how to do it in big business. So today, Piotr Hrvatko already have mentioned quite a really good, interesting things about how the stuff is going on in enterprise open source from the business side, and I'm going to concentrate on the technical side. So one of the things that usually considered as good by open source is the community support, that kind of hype, is the things that are sometimes called conference-based development, and so on, this kind of enthusiasm of developers. However, there is a small issue. The bigger project that becomes, the less important the things are. So for example, yeah, it might be very nice if you can develop a core of the application in one night. However, if you have already big application, you need to develop some kind of small component that has to be integrated very precisely and very specific with all other components. You have to spend about 2 weeks just only thinking about this integration without actually coding itself, and it's really not that fun, and not just a few people from community can allow to spend 2 weeks just thinking about this kind of architecture decisions. This is where help from community probably might end. Second thing is usually you can think is a good thing about the community, about the open source in general, the pull requests, that people can participate in your code, they can help you write the code, and can help you make your product better. From the point of helping the make code better, you have at least 3 or 4 ways to do it. Well, the most obvious way is just help the user application and find the issues if you have some, and maybe propose some kind of improvements and so on. So definitely it will work all the time, no matter big your application and small your application, it will always work. However, for example, if we're talking about actual participation in code development here, when the application becomes bigger, the code has to be written in a very precise way. It has very, very high quality. It has to be tested. It has to be approved by several layers of people. And actually, that's why the reason why we have only about 1% of the code in our core from our community. So it's in fact, when we are accepting pull requests from the community, we have very strict, specific list of rules how we do it. We have very specific code review standards when we are doing code review, and actually we are taking very seriously quality of our code. And from the other side, from the one side might be a good thing because we have still reliable code. From the other side, we are not, most of the community members are not allowed or they simply don't have time to build the code in this way. So you have to think about it when your application will grow, when your code base will grow. So you'll probably face with this issue, and maybe at your first year, maybe second year, but sooner or later, if you will become bigger, you will see it in your application. Despite the fact that my presentation called architectural trip and strips, I'm going to start about the ways to fail a startup. So I believe all of you here want participated in the startup one way or another, but I would like to ask you first, who actually failed the startup? Oh, nice. So we have about 4 or 5 people. Actually, it's a very good experience. If you fail a startup, it may sound very, very weird from the business point of view, but you learned a lot. You learn things you must not do. So when you are actually doing startup, you don't know what you have to do. You have to know 10 or 20 ways, you don't know which way you have to follow. And actually, knowing the ways you shouldn't follow, it's already half a job done. I know at least 3 ways to fail a startup. There are, of course, more, but I will concentrate only on these 3. So the first way is a bad management. So if management doesn't have vision, for example, you get investment, but management doesn't really care about what you're going there, so probably half a year or a year you will end up with failed startup. Second way is a bad marketing, which is you build a good product but you cannot sell it, so market simply doesn't need it, so it's useless, nobody will buy it, you will have no money, and startup will fail. And the third way is more interesting for us, is about code. So if there was a problem in the code, if there was a problem in the issues, for example, have too much bugs and so on, it's this very common thing you can find in the open source application, unfortunately. So there were 5 people about our auditory who actually failed a startup, and who actually failed startup because of the technical, the third level of problems. Okay, so it was only me, right? So the lessons, I can do some kind of explanation about this stuff. It was a small company based in Canada. We did some kind of social networks stuff, and we actually started with homemade core. We can call it this way, so we just plain of PPG, not a framework, nothing. We started, we had some kind of profit number at the end, and I believe in 3rd or 4th month decided to refactor it. We wanted to go to Zend. So this was the end of the startup. We simply wasn't able to produce features, and that was the end. So why actually I'm telling that default architectural tips and tricks? All the things I'm going to discuss today has its bad sides, it has its good sides. I'm going to describe both, so you will be prepared which side effects you may have if you follow some kind of standards. Talking about architecture, it's usually nice to imagine like real architecture stuff, like building a building with bricks, walls, some kind of stuff, and usually you are starting with a plan. So architecture is usually you have a plan, some kind of blueprint or white paper with a plan, and if you are doing real building, you usually adding something like that, which is pretty much standard building, what you have expected. However, if you're working in the IT industry, if you're working in the software development, you know that you may add with something like this. Because it's not even close to what you have expected, you don't really, it have different shape, it have different kind of lighting, it have different appearance and so on and so on. But this is a best case scenario, and in the real world you much often will end with something like that. It's pity to understand, but yeah, it's still a home, you can still live in it. And for most of the people, it's more than enough. So the main lesson here, think ahead. It might sound easy, but you have to think ahead, but in real life, before understanding all the requirements. You have to speak with the marketing department, you have to speak with product owners, you have to speak with the investors, what they kind of outcome they expect from you, what kind of things they expect from your startup or from your company to do. And this is a place where you need to do and understand what kind of way you have to follow to actually try to build something good. We did that. We succeeded. For now, we are still alive. Yeah, talking about modularity. We are building applications which consist of several modules. So you can just install a couple of modules together, application will work, and depending on the modules, it will have different functionality. And there are two ways to do that. There are several concepts we are going to follow, and we're usually following when we are working with the module application. It's small pieces, it's parallel development, it's dependencies, dependency management, different combinations of modules, and support, and of course standard common best practice with architecture. I'm going to follow this some kind of table of contents during the presentation. And starting from the modularity, there are two ways to build a module application. The first way is obvious, you can do it in a good way. For example, here you have a modules like a puzzle thing. They are connected together, but if you will remove one puzzle, the other will stay in place and you still be able to see the picture despite the fact that you have some kind of issue there. So for example, if you develop a module for some kind of marketing, everything else, and there is a bug and everything else has to work. And there is of course a bad way to build an application, bad way to do modularity. You can just drop the card from the basic and all your house with the broken. So this is not really a good thing, and you again have to think about these things ahead. So how to build an application to make it reliable. Let's start from the first topic, is the small pieces. So definitely modules are usually small, definitely it's good for the developers because you have to concentrate on this kind of small piece. You can write in 1 to 2 days up to a week. So it's nice to think, it's nice to work, it's nice to test it. So it's definitely good things. You can create it very easy, you can create it very fast. It's easy to maintain because you have just a couple of interfaces, you have just a couple of entry points for it and nothing really interesting in it. But small pieces have minor value for business. So business will ask you, why do you have created these 3 classes? You can ask them. They will be integrated later with some other component. Business to tell you, not interesting. Why? So before you creating small pieces, think about the possible values. And the second thing is not really nice, is never use dependency things mentioned about the integration. So think about the integrations and things about possible use cases, things about how they will be integrated all together, and think about all these things ahead. At least when you start developing a new component and start developing a new application, because it will save you lots of time in future, it will save you lots of time for your customers and clients, possible clients. And yeah, you have to provide simple interface, because if you have lots of small pieces, they have to be integrated all together, they have to work together, and this is some kind of contract programming when you provide just an interface and all the components has to write on this interface. And make it simple, make it small, because if it will make it complicated, it will be impossible to work with it with the other components. One more thing that usually people forget about, especially in the open source, is documentation. Because you may have a nice interface, you may have a good kind of methods there, this kind of signatures, but if you don't have documentation how to use it, what this interface do, why it was there, what is its purpose, and why this component at least exists, you will go nowhere, because documentation is the first place where developers prefer to look, because they, of course, they like to read the code, like to write the code, but if you have just a text described, you shouldn't do neither of those. Small pieces actually reminds me about the Lego bricks, because you have some kind of small, simple interface, you know how to put them all together, you know how to integrate them all together, you can build quite a complicated structure of these components, and yeah, they're pretty much robust. So this is, in my opinion, the best way you can build your application, build your modules. Second, one of the interesting concept about the module application, because you have module, because you have them separate, you can build them in the same way, you can build them parallel. Good thing is, of course, it takes less time. You have 2 teams, they're working at the same time simultaneously with the component A and component B, and at the very end you will have 2 components that will create in the 2 times faster. The problem, the good thing, it also indicates technical issues at the early stage. So, for example, if you have 2 teams that work on the same components, one of them might face an issue and you will know them much earlier. If you, for example, have standard linear way to build a component, linear will to program your application. Yeah, so now about the best stuff. Integration issues. Because they are built in parallel, sometimes they might have incompatible interfaces, sometimes they might not work together, sometimes they don't fit together in the proper way, and you have to remember about it, you have to take it into the account. Second thing is the synchronization issues. Despite the fact that you are usually planning how teams working, you might face unexpected delays. For example, when the component A, B, and C already working, component that combine all them together might be still in production, and basically you have no code, you have nothing to show, it doesn't work. You have to remember about all this stuff when you're developing the code. So how to face this, how to fix these issues, how to at least minimize the amount of pressure when you will see, when you are happy if you're working in the parallel development environment. So the first way is continuous integration. You know it's continuous integration, right? Nice. So continuous integration helps you to check every integration as soon as possible and indicates those issues as soon as possible. You might still have synchronization issues, but at least you will be able to see when they're coming and where they're coming, and at least try to maybe speed up the process of one component and slow down of the other component, and so on and so on. Second thing you can do about this kind of stuff, you can avoid dependency between the teams. Because, for example, if both teams require the same component at one point of time, it might be blocked by other components, and this is not the things that you want to have. If you want to make parallel, try to make parallel or separate backlogs, separate streams of work, and each of these streams has to be as independent as possible from the different streams. Talking about parallel development, I usually like this picture. Do you know what it is? Yeah, termite mound. Yeah, this thing called termite mound in English. It's basically the place that's built by termites, and if you will see here, you will see this kind of lots of tubes that were built all together. You will see that maybe look a bit weird, maybe sometimes a bit ugly, but you can see that they in fact were built parallel. And so this is a good example of how it can be built parallel. Yes, it has its flaws. It's not that nice. It may be not that perfect, but it has fulfilled its purpose. The termites can live there. They can actually live there for 50 or more years because the thing is pretty robust and pretty strong. This is a thing I can consider as a good example of parallel development in nature. Next thing that usually people don't think about is dependencies. Talk about dependencies. For example, our platform have 50 or so dependencies. You may think that it's a lot, but in fact, when you try to have a look at the code we have there, it might appear that we have even more code in our dependencies. But let's return to the dependencies thing. The good, of course, you can reuse the code. You cannot write things from scratch. You can just get it somewhere from GitHub or whatever you prefer as a data source, and you can just get it, reuse it in the way they were intended to build. But structural dependencies is the first problem. If you're building your own components, you can easier find the situation when you have a component A depending on component B and component B depending on the component A. So you have just two problems here. First, either this is a separate, these separate modules are in fact one big module, or you have pretty much messed with your architecture and you have a problem, you have to solve it on the code level. What you can do with it. So the first thing, again, ahead, you have to think about the components, you have to build dependencies tree. So you have to specify what the components have to depend on each of your levels, and what kind of dependencies you have there, and you must have no circles, no loops in this kind of graph. And if you think ahead about this kind of stuff, it will save you lots of time at the later stage of your development, or maybe in the production, when, for example, somebody asks you to just remove some piece of your functionality from your product because he doesn't need it. And you can also separate some pieces of your components as independent components or libraries. You can publish them, you can sell them, again, it's up to you to decide, but still it might be a very good thing that you can do if you have circular dependencies, or just make one of the components completely independent. When people are working with dependencies, you usually imagine something like that. Very simple graph, you have three components, A, B, and C. So nothing really complicated here, you always know this dependencies tree. But here in production, you will usually face something like that. And this is not a joke, this is actually a real graph of the components. When we have started our platform at early stage, we faced something like that, exactly. So this is not a joke, this is unfortunately a crude real life of the development. What you can also do with the modules, the good stuff about them, you can combine them in different combinations. Depending on the combinations, you might have lots of interesting features, either enabled or disabled. You can customize your product based on the needs of your customer, of your client. So, of course, it's a good thing. You have a very flexible application. You can customize it. You can set up it according to the precise requirements. Yeah, you can match exact needs of the business. You can match exact needs of the person who wants to work with it. However, the higher number of your components, the higher number of combinations you might have, and especially if you have interfaces that are changing over time, you make sure you may face a problem with backward compatibility. You might face a problem with versioning. You might face a problem to make all these things work together. If you have here some people from the Linux core, I mean, who work with the Linux core a lot, they know what dependencies hell. It's actually next kind of thing. Dependencies hell, if you have so many dependencies, you cannot handle them, and you don't know all dependencies that depend on dependencies. And if you're trying to build all this tree, you're just getting, your mind simply can blow off. In this case, it will be a huge problem for you. What to do with it? So what you can do is to combine some packages in the most common way you expect them to use and provide them as a standard package. For example, you know that there is a standard package for small business, you know that there is a standard package for the middle-sized business, there is a standard package for big business. Call them big, middle, and small, middle, and large components and pack them all together. And you have to think about coverage of the business needs, but of course, but if you will do it properly, 99% of the customers will use one of these packages. It will save you lots of time when you will be doing testing, when you're doing some kind of support stuff, because you will know exactly the list of the components you're working with, and it will be specific, and you will know what kind of issues you can find there. You can also test this kind of standard packages, but also you have to test minimal combination, maximum combination, because there also will be people who will try to make it the biggest possible way and the smallest possible way. Is actually two ways of optimization: the smallest way and the biggest way. And you have to remember that there are such people, and you will definitely face them in production. So just test them in continuous integration. At least you will be able to find lots of issues at the early stage, and not only issues package, but also issues in the integration between the components here at the point. Yeah, one thing that might help you is a versioning. You have to specify a version of your application, and if you're releasing code in one package, it's usually better to synchronize this release. For example, you have packages A, B, and C, and the first version 1.0, 1.0, 1.0, then the second version might be 1.1, 1.1, 1.1, even if, for example, was changed only in the package called A. So in this case, it will be easier for you to work with the version. You have to know, you will know in this case, that all the package has to be at the same version. It will help you lots of time during the debugging of the dependencies. And of course, if you have packaging, you have to use package manager, because there you can specify a package manager, you can specify a version, you can specify the package, you can specify the specific major, minor patch release if you're using this kind of thing, and this definitely saves lots of time for you as a developer, and your customers will be probably more satisfied with this kind of packaging stuff and versioning stuff. Again, Lego blocks. So from the same set of blocks, you can build different things. So here you can see 5 of the possible ways. When I was a child, actually, I had something like that. It was really fun to build something that actually developers were not intended to make it work, and it was really fun. In fact, if you can make it work, one of the fun things with open source. Next thing is the support, and here things can go very wrong and very, very fast. Well, talking about the support, it's of course, if you have packages, it's very easy to localize the issue. You have very small pieces of code, or relatively small pieces of code, you know what kind of steps or reproduce you have for the issue, and you can easily localize it one of the packages depending on the nature of the issue. However, first, it might be not clear where to put the fix. For example, you have a bug when component A and component B works together, but separately component A and component B doesn't have this bug. You have to specify, you have to know either you're creating component C or putting to component A or to component B. So you have these 2 choices, you have to make this choice every time you put in the fix there. The fix may affect several modules, so exactly the same situation. You may not understand which kind of module is responsible for this fix, and you may not understand in which situation this issue might be reproduced. So think ahead about this kind of stuff before you start applying the fix. And if you would do it properly in the very beginning, I mean, before you go applying the fix, it will save lots of time and future reasons, because you will not face this issue again in production. Your fix might affect several versions. Yeah, for example, you have 3 packages, you have 5 versions, so in fact you have created 15 pull requests. Which just might sound fun, but it's not fun when you can actually try to do it manually, or automatically you have quite a lot of branches and quite a lot of mess in your GitHub history, which is again also really not a really good stuff. You have a few changes in scope. If you have QA engineers, and for example you want them to fix it again, each engineer has to install the proper version of each package, combine them all together, and again we have the same 15 combinations we talked about with the fixes. What you can, final thing, backwards compatibility. You have to care about the versioning. If you have to care about the version, then you have to care about the interfaces. So you have to know, you have to specify which kind of version can be upgraded to other kind of version without breaking your functionality. If you're providing only a core, it's not a problem, because you know that you test your own core. However, for example, if somebody else did customization to your core, you have to make sure that customization will work. So things to do with this. First, you have to have very strict responsibility of your modules. It can help you fix first 2 issues. In this case, you will definitely know where to put your fix and in which module this fix to be and which modules has to be affected. So, for example, a QA engineer in this case might test only this kind of small scope instead of the big one. Next stuff is single code storage on a Git repository, so you can put all your modules in one place instead of putting them in different repositories. In this situation, this scenario, it will be easier just to maintain versioning, because, for example, doing 1 commit, not 5 commits for different 5 components, and so on and so on. In fact, we have moved to this monolithic repository approach only after a year of developing of separate modules. It was really good. So before that, we have to do, for example, Git with submodules. Now we're using only one repository where everything put together. And when we are releasing the thing, it just simply copies the appropriate directory specific Git structure to the separate repository, and that's it. And of course, you need to have good versioning strategy, because in this case, you have to know what kind of version compatible with what kind of version. And again, aligning this can help you a lot in this scenario. And of course, the final stuff is again sort of the common approach, common good stuff is and continuous integration. If you're writing lots of automated tests, hard unit integration, or functional, whatever you prefer to write there, they can help you and save you a lot of time. And for example, you shouldn't test manually all the stuff. You can just put to the test some kind of specific versions. One good thing about the versioning, you may also specify a thing called LTS, long-term support versions. So in this case, you will not support, for example, 10 versions that were released until 5 years ago. Yeah, you will support only 1 version that was released 5 years ago, but was released 3 years ago, 1 version was released years ago. So you're supporting only 3 versions instead of 10. Talking about the support, I'm also thinking about how people build the car, because car is a very complicated stuff. It contains lots of the pieces together. And it's good if you scratch the door. You can just remove the door and put a new door together. But for example, if you have some kind of minor issue in the engine, you have to put the engine, you have to disassemble the engine, you have to find the issue there, which is a type, and you have to assemble it again, and you have to put it in the car again, and so on and so on and so on. So the better you will think about your architecture, the better you will build your architecture, build your structure, the easier it will be later for you to support it. So it will save you time, save you money, and so on. And of course, common best practices, which is a common thing. They are not only for mobile applications, they are for all applications, but you still have to remember it's very, very good stuff. It's solid keys, dry, grasp, YAGNI. Any explanation required here? So I believe, yeah, let's do it. So solid is just about thinking about single responsibility, keeping things separate. Keys is about thinking about keeping things simple. Dry is about don't doing copy paste. Grasp is just sort of combination of all possible and good patterns you have in software engineering, like low coupling, high cohesion, entry points, and so on and so on. And YAGNI is about don't do what you really don't need to do. So where you can use TD, where you can use some kind of agile plugin, can just throw off the backlog what you need to have there. Of course, the code review. So in our company, we have code review standards, which contains about 40 or 45 items grouped into the sections. Then, of course, there's other tests. Again, standard best practice, unit test, functional test, hard test, depending on what you want to have there. Of course, depending on the level of your application. Continuous integration to run all these auto tests, but in the continuous integration, you may run not only auto tests. Continuous integration, you can run some kind of health check. You can run code analysis tool. You may run tools, for example, checking code style. You may run backward compatibility tools that, for example, install application with the older versions and check whether all interfaces are compatible there, and so on and so on and so on. So just keep these things automated because developers will forget about 100% sure. And documentation. It might sound weird, but for example, when we have started, we have almost no documentation at all, and our community weren't really happy about it. So now we have a couple of tech writers who are responsible for filling documentation, maintaining documentation, and again. So this is how we trying to make our community happy and trying to help our partners and customers to build applications based on our product. In the very end, if you're working with architecture, it's between finding a balance. So on the other hand, you have technical challenges. You have to thought about development speed a lot. You have to thought about the extendability of your application, about the complexity of application, how easy to install, how the customer can work with it, how to help them in to understand how application works, some kind of functional training, when developers training, and so on. But from the business side, you have different kind of challenge. Business always have new features. All this stuff, of course. Businesses care about development costs, so it may basically about reducing the time that development of each new feature will take for you. It's support cost because support actually people also have to pay money to the people who are doing support and again and again and again. So this image actually demonstrates how easy it is, because sometimes it's not that easy. And actually, every time you're doing some kind of decision in your architecture department, you have to think about the good stuff, about the bad stuff, and think about what if happen if I will apply this feature, what will happen if I will not apply this feature. And if you build this kind of separate scenarios that you will can follow, and you can choose the best of them, and you can at least have some kind of arguments or pros and cons. So here's the good stuff, here's the bad stuff. You can compare list of this stuff and think about them in future. And if you are pretty sure that that kind of architecture decision will help you, go on and implement it in your code in your application. That's all from my side. If you have any questions, I will be happy to answer. You can also ask questions in Polish. No questions? Right, guys, so thank you very much then.
Będzie jeszcze ostatnia okazja, żeby skorzystać z posiłku, bo chłopaki jeszcze czekają z kiełbaskami, więc jeżeli ktoś przed ten czas zgłodniał, to jak najbardziej jeszcze można się załapać na to, ale to za 5-10 minut wracajcie i drugi kolega z Wro będzie miał swoje wystąpienie.